we found the area of a disk, when we proved it was equal to pi, we used a weird substitution. We had an integral with a square root. We had an integral that looked like this, and we used theta was arc sine of x, or what we noticed is that you could actually say that x was sine of theta. And this we like because sine of theta is one of the functions we're comfortable with, arc sine a bit less. Alright, so what we want to do now is we want to learn from this trick, and we want to apply it as much as possible. So here's the trick. So we're going to use this trick so we don't have to be as clever as we were just in the last example. We want to have tools to use instead of instinct. So our trick is going to apply on integrals that have square root of something like that. So I'm going to be a bit more flexible. I'll say instead of 1, a squared. So if I have root of a squared minus x squared, then the substitution I'm going to take is x equals a sine theta so if I take the derivative, I'll get a derivative of sine is cos. Alright, so that's nice. I have a nice way of writing dx. And now I want to know, well, what does this have to do with this square root? Well, for this, I'm going to go back to the triangle. So if you notice here, I have that sine theta is x on a. So if I want to draw my triangle, like we did when we were simplifying inverse trig functions, if I go back to my triangle, sine theta is opposite over hypotenuse. So opposite, I'm going to take it to be x. Hypotenuse, I'm going to take it to be a. And the third side is not clear from this, so let's call it b for now. Now, if you look at this triangle by Pythagoras, I'm going to get that x squared plus b squared is a squared. And if I solve for b, I'll get that b, it's a length, so let's say it's positive, is a squared minus x squared square root. So this b is square root of a squared minus x squared. That's what we have in our integral. This is the reason why the square root appears in arc sine. It's also the reason why the square root is going to lead us to this substitution. So the final part of this trick is how can I replace the square root in my integral with some function of theta. So square root of a squared minus x squared. Let's do it the long way since it's the first time. I'm going to replace x by a sine theta. Let's multiply it out. I'm going to factor a. This is cosine squared. This is going to give us, let's say a is positive. You can always take the positive root of that number, so that works. So a square root 1 minus sine squared is cosine squared. And so I get a cosine theta. Alright, so that's going to be part of the trick. Part of the trick is that this square root is a cos theta.